the background pictures will be occasionally something like this. I should mention that we took all of these pictures with a 60mm Hasselblad. That Victor Hasselblad, the late Victor Hasselblad, had designed specifically for the Apollo effort. It was the first time that a camera had electric drive, for example. One of his cameras had electric drive. And the film that we had was a Kodak film. Any camera buffs in the crowd? Kodak 368. So you may remember this. It was a late Ektachrome film that was just fantastic. It didn't have that magenta problem that Ektachrome had early on. And that's what these pictures were taken with. And that film has been, for 35 to 40 years, in refrigerated storage at NASA. And in the last 3 years, after I spent many decades trying to get this done, NASA finally, on their own, decided to bring that film out and digitize it. This is a start at that. This is it's halfway there. This is much, much better than anything that I've been using in the past. And the next phase of it, this is all being done at Arizona State University, will be even better. That film is just outstanding. And they're starting to pull out the kind of colors that I could see in the lunar materials, both on the ground and from orbit, which disappear when you try to print directly from the film.
Senator, is that color?
That's color.
Yes. How close is that to natural color?
That's pretty close. Yeah, and in particular, the new digital images will be. It'll be just, the film, as near as I can tell, and I looked at the film after I came back with magnifying glasses and looked very carefully at it, and the colors in that Ektachrome 368 were what I remembered. I can't say great rendition of color, and this is that. You'll see some other things here shortly. That's about it. Now, meanwhile, back on Earth, a couple months before our launch, our Saturn V rocket was being rolled out of the vehicle assembly building to the launch pad. 364 feet high. When it was fully fueled prior to launch, weighed 6.8 million pounds. The largest rocket ever used to put human beings in space by a significant amount. The space shuttle has maybe, I don't know, 80% of that size. Now, just to give you an idea how fat, this is how large things are. This is a large fire truck. Oh, red spot down there.
This thing crawls.
Yeah, and this crawler is based on technology. The thing that about 1 mile per hour out to the launch pad is based on the technology from the Iron Range, used a long time ago for mining. The vehicle assembly building at the time was the largest enclosed space on Earth, since have been eclipsed at least by the Mall of America.
What would call this progress?
Yeah, if not many other structures. Now, I don't show this just to show you how we all age. But when I heard that Snyder was going to be here, I wanted just to point out, a lot of people see this suit, this picture, or something like that, and they wonder, what in the world are all these things? The blue represents input to the suit. Oxygen, communications, water, things like that. We had water-cooled underwear, so we had to have water go into the suit, okay? The red is output. This particular one is an exhaust, had a hose on it, exhaust back to go through a lithium hydroxide filter to get carbon dioxide out. This one was an emergency exhaust in case we had to use our emergency backpack oxygen, which we never did. So that's why you see that. And now, launch, December 7th, it turned out, Florida time, December 7th, 1972. 7.5 billion pounds of thrust. These specks here are pieces, large slabs of ice coming off the rocket. We were 2 hours and 40 minutes late leaving because of a computer glitch in the launch computer. we can talk about later if anybody's interested. And so Florida being as humid as it is, we condense frost, thick layers of frost on the sides of the rocket because of the ultra-cool hydrogen, oxygen that are in the fuel tanks. So it just froze on the outside. But it almost all came off with the launch, but not quite all. We went into orbit for 2 orbits, 18,000 miles an hour, and then accelerated to 25,000 miles an hour in order to reach the moon. And when we shut down the 3rd stage of the Saturn V rocket, there was a bit of a shake, and then some other pieces of ice came off that 3rd stage. Now this is what I think John Glenn saw and reported seeing over Australia, and suggested they might be fireflies. John is the retired Democratic senator, and that might explain what he thought he was seeing. This picture of the nearly full Earth, not quite, Mediterranean at the top, Antarctic at the bottom, is still the most requested photograph in the NASA archives. And I took this from about 34,000 miles away. And over the next 3.5 days, as we went to the moon, I had a chance to practice my weather observation, which I'd grown up doing with my father, but on the whole globe, and particularly on the southern hemisphere. And if you look carefully, going into the subcontinent of India here, is a very large cyclone, hurricane, and or typhoon, I'm not sure. Do the Indians call them typhoons? Yes. Because I know in the Pacific they're all typhoons. And in fact, in observing the Pacific, I identified a typhoon nobody knew anything about for about 4 days. In about 4 days, they started to pick it up on the charts, but you could tell it was a typhoon about 4 days. We were headed to a place on the moon, right there. This picture actually was taken on the way home, and about a third of it is the far side of the moon. That's the crater Tsiolkovsky on the far side. This is Crisium. And Neil Armstrong and landed on the moon right there. We were north of him a significant amount in the ring of mountains surrounding a 740-kilometer diameter basin, Schmitt, a basin that we now know formed about 3.85 billion years ago from the samples that we were able to return. And Neil's samples were about the same age of the Mare basalts.